So NPV was the best method, but we also have internal rate of return to talk about. And internal rate of return is the rate that forces the net present value of a project to equal zero. The IRR equation is the same as the NPV equation, except that to find the IRR, the equation is solved for the particular discount rate, called IRR, which forces the project's NPV to equal zero, rather than using the weighted average cost of capital in the denominator and finding NPV. So here we never have to use a weighted average cost of capital to calculate the IRR. We only use it in a comparison type way. So in the NPV method, a discount rate is specified, the weighted average cost of capital in other words, and the equation is solved for NPV. But in the IRR method, the NPV is specified to equal zero, and the discount rate, which is the IRR, that forces this equality is found. It's very easy in the financial calculator. You're just going to enter the cash flows, and then there's an IRR button over here. Okay, so let me find the cash flows and we'll calculate the IRR for project L and project S. Let me go back through and pull this one up. Okay, so for project, let me look in my cash flows to see which one I have. Okay, so I have project S still in my calculator. And so all I have to do is go to IRR and hit compute. And when we go back to that slide, we'll see that the IRR was 23.56%. Then if I wanted to find the IRR for project L, let me go down, I can overwrite these numbers, hit enter. Cash flow 2, I'll override it with 60. And cash flow 3, I'll put in at 80. So now I have project L's cash flows in there, and I go to IRR. It just keeps the last number here that you had, so just remember to hit compute. And I get 18.13% for the IRR for project L. So let me find where we were. Right here. So we found 18.13 for L and 23.56. And so we're basically using the weighted average cost of capital number of 10% just to compare to these two numbers, 18 and 23. And if the IRRs are greater than the weighted average cost of capital and they're independent projects, then we would accept both of these because 18% and 23% are greater than 10%. If these were mutually exclusive projects where I have to choose one of the two, then I would choose project S because its IRR is greater than the IRR for L. And if you got an IRR of like 8% or 7%, we would reject that project because it would be less than 10%. And so we can note that there's a similarity between calculating the IRR for a project and the yield to maturity on a bond. If you remember when we calculated I on like a bond problem, basically that was the interest rate that made the present value of all the future coupon payments and the repayment of principal equal to the present value, the sum of that present value equal to the present value, the cost of the bond today. So it was like the rate that forced that equality. I think here's an example. A 10-year bond with a 9% annual coupon, $1,000 par value sells for $11.34. You solve for the yield to maturity of 7.08. That means that is the rate that makes the 9% coupon, the $90 coupons for 10 years and the $1,000 received at year 10, when you discount all that back, that is exactly equal to 1134.2 if you use 7.08%. So they're the same thing. So what's the logic for this IRR method? Well, IRR measures a project's profitability in the rate of return sense. If a project's IRR equals its cost of capital, then its cash flows are just enough or just sufficient enough to provide investors with their required rates of return. An IRR greater than the weighted average cost of capital implies an economic profit, which goes to the firm's shareholders. But an IRR less than the weighted average cost of capital indicates an economic loss, or a project that will not earn enough to cover its cost of capital. Projects' IRRs are compared to their cost of capital, or they can also be called hurdle rates. Project L and S both have a hurdle rate of 10%, and both, like we talked about, have IRRs greater than the hurdle rate. So both should be accepted if they were independent, but if they were mutually exclusive, again, we would choose Project S because it has the higher IRR. One other thing to consider is a question like this. Would the project's IRRs change if the weighted average cost of capital change? No, they would not change because of that. The IRR is calculated totally independent of the weighted average cost of capital. So IRRS and IRRL would remain the same numbers even if the weighted average cost of capital changed. Now, the thing that would change is the acceptability of the projects. Project L would be rejected if the weighted average cost of capital were greater than 18.1%. And then S would be rejected if the weighted average cost of capital was greater than 23.6%. So changing the weighted average cost of capital only affects the acceptance or rejectance, if that's a word, of the projects.